Hi, I'm Russ. I want to talk about two items from NFPA 921 titled Settle Burns and Heat Shadows and how they can be used as forensic tools in fire investigation. So settle burns happen in a couple different ways. One is when you have concentrations of energy transfer into wood, you're going to have charring. So if you have fire, let's say there's an item burning, a box of something, a couch, even ignitable liquids, if you look at the subfloor, it's going to have a localized pattern for char that's going to transfer through that floor down into the wood studs. And there's a variety of depths, there's a variety of configurations you can pick up from this kind of a burn. But regardless, what you're going to see are different patterns under the subfloor associated with burn patterns on the floor joists. That'll help identify locations of where a fire might happen. Similarly, you can have U-shaped burns, settle burns from ventilation directed flows in ceilings. But specifically, the forensic tool I think is most beneficial in understanding or reconstructing a fire from what may have happened on the floor. Here's a couple examples from the U.S. Fire Administration. Um, so the image on the left is from ignitable liquids, and you can tell that it's kind of interesting. You can almost see burn patterns where ignitable liquids flowed under the floor, the subfloor. That it wasn't necessarily a heat flux induced pattern. It was more from ignitable liquids on fire. But you can see the kind of patterns generated on the image on the right. I think in this one it was a ignitable liquid on the floor, but similar patterns could be from cardboard boxes or other kind of items. Heat shadowing happens when something blocks the radiant heat flux and basically protects a surface. So you can tell how an item was placed against the wall. It has a different pattern behind it. And that's simply because the amount of heat flux that was allowed to transfer into the wall was limited because of that blockage. Time, distance, and shielding are the fundamental rules for heat transfer. You want to minimize time, maximize distance, maximize shielding. Those are the factors that go into radiant thermal energy transfer. So it's useful in determining that a fire did not happen behind the blockage. Basically, these tools can be used to pinpoint the general area where the maximum heat flux occurred, and that can help narrow down on where a fire origin occurred. Here's some examples that I think are interesting. So this image, top left, the clock that's on the wall, it's not removed. Behind that, you'd be able to clearly see a blocked energy flow. So it would have a clearly defined line around that clock where heat transfer was limited. The example in the middle comes from an automotive fire. And this is a line of wire, an aftermarket wire that was analyzed because the concern was, did the wire cause this fire? And what you notice is that this arrow here points to the wire that was protected, shielded from radiant heat flux by this item here. This section of the wire was not protected. It received the heat flux from the fire on this side. So it helped you identify that the fire probably happened over here and that wire was not the source of that fire. Here's an example, bottom right corner image. You can tell that a couch or something was at this location and that it shielded the wall from significant heat flux. A few other examples. This location, this is actually the result of a fatality that protected that protected the floor from radiant heat flux. During the overhaul process and search and rescue, firefighters are frequently going to go in, overturn materials, move items. In this case, these images here, center and bottom right. What likely happened is after the fact, a fire investigator went in, picked up the chair that they found outside. Frequently, these chairs will be thrown outside just to clear the area. And that fire investigator placed it back in its location. But you can see that the chair and likely the cushion insulated this area from burn, resulting in these particular patterns. So it was just really left to guesswork on the part of the fire investigator in reconstructing this area where that chair went. or what might have been at this location. So there is some possibility that they are wrong in that, but it's something that you need to consider when you're scrutinizing data. Here's another example. This was a laboratory test. You can see this, the locations of the book and the other items clearly leaving this pattern on this coffee table. This was a short presentation. It was just to equip you with an understanding of these two principles, the shadow effect and the protection from heat flux. Some additional references that you may benefit from are included in this image. If you have any more questions, feel free to leave them in the comments and I will address them. Thank you. Have a good day.